morning. Thank you for the invitation. Thank you for the organization. And I love the great work that you guys are doing. I grew up on a farm, and I've been a research scientist my whole life. But the research I do is very different to most people, because having grown up on a farm, I realized that the people who are managing the land are the ones who are going to decide what happens. So as researchers, if we want to get our stuff practiced, we have to work in close partnership with the leading farmers in order to have things used by them. Otherwise, it's just another paper floating around in the wilderness. So you'll see a couple of different things. Now, I work with a group of scientists, 14 of us, from 10 disciplines, covering soil microbes all the way to social issues and economics, large-scale economics. And the goal of our team is to find out what grazing management results in the highest soil carbon. Now, normally I would be very critical of someone who only just aims at one thing. But when you think about it, Keith's talk yesterday was absolutely first class. The complexity of what we're dealing with, what single thing actually encapsulates all of those things? And it is, in fact, carbon. So, for numerous reasons, all of them here, these are fundamentally important things. 2015 was the Year of Soil, International Year of the Soil, and the scientists right around the world stated unequivocally, if we carry on managing the way we're doing it at the moment, we've got about 60 years left of soil, because we're losing so much soil, and also functional soil. We are destroying the function of the soil because we have destroyed so much of the carbon. That's the bad news. The good news is there are really good farmers and ranchers in North America and in the rest of the world who have actually improved the amount of soil carbon by a great deal. Those are the people we work with. When I started, A&M recruited me in 1990 because of my knowledge on regenerative grazing. When I started working on regenerative grazing in this country, I found out from various networks, from the Sand County and other people who issue grazing awards, from the NRCS, the guys who've done pulled soil cores right through North America, and also the labs. We visited the labs to find out, okay, who has actually got the most carbon in the soil? This probably won't surprise you. Over 90% of them were using intensive grazing, holistic management, Stan Parsons, Ranching for Profit, or MIG. And I have one collective term for that, adaptive multi-paddock grazing, that encapsulates that genre of management. Wherever I've been in the country, I've been a research scientist since '72. I've visited every grazing nation in the world. When I visit them, I make arrangements beforehand to visit their leading ranches. Every single one of them in every country I've been to follows AMP grazing. So there's a precedent for this. So when we started doing our research with Nathan, I'll explain in detail later on. But I'm going to lead up to exactly how we did our research, but it was at the ranch scale, commercial ranch scale, because A, the ranchers were doing a better job than the researchers in grazing. There's good research out there, but not in grazing. The ranchers who are doing a good job are 20 to 30 years ahead of academics. Those are the people we're working with. So let's start off with why we're concentrating on soil health and carbon. 90% of soil function is mediated by microbes. Keith explained this extremely well yesterday. So the way you manage the plants and the landscape is critical to using all the functions that life on Earth depends upon. The biggest limiting factor in rangelands and in agriculture is not the amount of rain you've got, but how much you get in the soil. This is a picture, from in Mexico. This ranch, prior to this photo, looked like that 10 years prior. 30 years after that picture, the neighbors all still look like this. The only difference is these guys practiced AMP grazing very, very well. There's some excellent operators down in Mexico. And they captured nearly all their water. Right. In order to make an ecosystem work, you have to capture the energy. The energy drives every living thing. Photosynthesis, capturing it, turning it into sugars, and then that feeds A, the plants, which feed the animals, but B, feeds the soil microbiota. Hydrological function, that we've just spoken about, is fundamentally important. The mineral cycle, this has to be functioning well. You can have all the right species there on your property, but you can manage it in a manner that does not cycle the nutrients properly and does not have good water relations. So you've got to understand how to do that, and that's the guts of our research. So you've got to manage the plants so it has community dynamics below ground and above ground that actually make these things work really well. But within a year, you've also got to manage adaptively as the seasons change to get there. Let's now look at what happens in the normal continuous grazing. Most people use continuous grazing and heavy. This is an area, 3,000 acre area in South Texas. Those green dots are GPS collars on the cow herd through the year. And the one thing you notice straight off is they do not graze uniformly. They ignore certain areas. This is at NRCS type stocking rate, and they will camp on those areas. Now this is the size of areas that most research is conducted on. Even if you had the same stocking rate in there compared to there, you can clearly see from this picture that there's no way that you will get the same impact on the environment or a landscape looking at these areas when you should be looking at that whole area. This is one of the major reasons why we work with commercial ranches and we measure, okay, what is the heterogeneous impact in a commercial scale, because this determines what's going to happen. What happens at each one of those green dots? This is what happens. They concentrate on patches that they really enjoy, and they keep nipping them down, and these plants are not hit too heavily at all. So in terms of light capture, how good are we doing here? You might be doing reasonably well here, but not here. What do you think the roots are like here? Shallow. The first drought or two that comes along, and suddenly that turns into that bare ground, and you don't go back. If you carry on managing the same way, you do not go back. So this is a direct product because of patch selective grazing and lack of recovery after grazing. So what we've seen right around the world is you can take a continuous grazed pasture that even under light stocking and that, you get more bare ground than you would have otherwise. You can turn this into that just with regenerative AMP grazing, adaptive multi-paddock grazing, where you have water runoff and losing carbon to actually capturing it and turning it around. And I've worked in areas from 8 inches to 80 inches, and the same principles apply. You just got to manage slightly different to apply the principles. So what you do, and this is regenerative AMP grazing, is you divide these areas up so that you can put the animals in one paddock so that they've grazed it the right amount before they move on. And you do each paddock like that, and you don't come back until they have recovered. And that's the key. You might need to put water in to make sure that you've got good distribution. But these are all the things that you can control. And this is what makes the difference between continuing the decline in your resources or actually regenerating them so that you can build on. So the normal type of situation that you would find is a couple of paddocks on a farm. There'd be a single herd in these managed continuously. Or you might put all the animals in one herd and move them around there, offering a period of grazing followed by a period of recovery. Does that solve the problem? Not really. So what people have done is, there are numerous ways you can subdivide each one of those areas, but let's just take that as a grazing unit there. That previous paddock divided into 8. Do you think that'll solve the problem? No, and let me illustrate why. People conflate overstocking with overgrazing. They're two separate issues. Overstocking is when you've got too many cattle for the amount of grass that's there. So part of the adaptive management is making sure that you've always got enough grass at any point for the number of cattle you've got. If you haven't, you need to have organized a plan where you change that so there is enough grass available for the cattle. Overgrazing occurs when the animals are grazing for too long a period. They go back to those same plants and nub them off, keep them short. And if you come back too soon after grazing, i.e. they have not recovered properly, that's when you start going backwards. So even if you're moving through 8 paddocks, you're going to be grazing for a week or 2. Then people generally say, oh, 60 or 70 days rest is going to be good enough. We found out, no, it needs to be double or triple that depending on where you are. So the guys who really made a success of this, they will divide up their whole place, and they might, the beginners will want to have just a single herd in each one of these things. But they only have limited success because of the length of grazing period and that the recovery period is too short. The people who have had the most success, particularly during drought periods, are those who put everything in one paddock, the whole herd, together, and they go through these areas. So they have very short grazing periods, a day up to 3 days, and then they have recovery periods of 90 to 120 days. And that is what has produced the good results of building the soil back to what it is, building the plants back to what it is, what they should be, having deep roots so that they can handle the droughts, and developing the increased microbiological activity that restores the micro and macro aggregates that allow most of the water to go into the soil. So these are the people we've been working with. And examples, one of the first group to do this was the Noble Foundation. They had a poorly grazed area, lots of weeds, a couple of decent grasses in there. And normally people would come along and with the advice that, no, you need to spray there to get rid of the weeds. But that doesn't help. Why? Because in 3 years' time you've got to come and spray the weeds again because you haven't got rid of the causal agent, which is poor grazing. So what they did was they divided the area up into 18 paddocks with a watering point, and they moved the animals through there, specifically looking at the species that they wanted to prevail, grazing them moderately, getting off, only come back again when they had recovered. So these are results they got. And Hugh was in the room. He was there with Charlie, who was first class, Charlie Griffith. These are the number of grazing days, the years over which you can see there, almost a 4-fold increase. We've got farmers here at Henrietta who've achieved that in, Tony, 8 years. They've increased the number of animals they can carry and just about got rid of their bare ground on their property. Huge increase. Now you'll notice here a couple of blips. What are those due to? The odd drought that comes along. So you just apply your principle, make sure you've got enough grass for your cattle. If you haven't, then you get rid of some of your cattle. But you have a short grazing period with a long period of recovery, and you move forward. So these are the things, these are the keys. In order to get increased profits, you aim to improve the ecological function, and those will deliver increased profits. That is the way you need to look at it, not just say, okay, what are we going to buy now to increase our profits? No, you increase the function, and that makes it work. Have flexible stocking, so when there's less grass than you need for the cattle, you change the cattle numbers. In the long term, that is a much cheaper thing. If you buy in hay and keep them going, you keep degrading your resource, and your bank manager will call you fairly quickly. You need to spread the grazing over the whole ranch, grazing one of those paddocks at a time, so that each one is grazed properly and can be afforded a decent recovery. Grazing moderately in the growing season, because when you move out of a paddock, you want to leave enough photosynthetic material there to be capturing the energy, feeding the soil microbes, and growing the next crop of grass before you can harvest it again. Use short grazing periods because that minimizes the negative effect on the plants, and it also keeps good nutrition in front of the cows all the time. So if they're moving quickly, they're in a more constant plan of nutrition, not a seesaw plan of nutrition, and they do much better as a consequence. This is the key. Probably the most important thing is adequate recovery. Now, you've got to know what to look for. You know the growth curve of plants. You start off you graze it down, and then it's going to grow up. And before it starts setting seed again, you need to graze it so it comes down again. It will then remain vegetative. So then you can harvest it numerous times, get 3 or 4 harvests during the season, and you always got good nutrition in front of the cows. In dry country, it's a little bit different. We'll talk about that later. And the key is to adjust forage your moves as the growth rate changes. So you've got to look at the recovery of the plants to know when it's best to graze again. Might sound difficult if you haven't done it before, but some of our best grazers have just got a high school education. They pick it up, they look for it, they look for the right things, no problem at all. Many of our best guys come at that level. So the reasons that for failing to get positive results: increasing your animals too much before the soil and the plants have improved. In most of our areas, you can institute improved management, and it's going to take, in the 30 inches of rainfall, it's going to take 5 years before you start seeing, okay, we're producing more, now we can consider increasing things. But in dry areas, down to 15, 20 inches, you've got to wait longer than that. You can see the building, you can see the cover on the soil improving. It's only when you're producing more grass that you should actually improve the number of animals. You've got to plan adequately, and there are a number of good teachers around who can teach you how to do that. You've got to have adaptive management. If you just say at the beginning of the season, I'm going to graze in the fast-growing cereals for a week and give them a rest of 60 days, and you're just going to stick to that all the way through, that is a recipe. That doesn't work, because in a wet season, you need to move quicker than that. In a dry season, you need to move more slowly. And all the research we've done shows that if you are adaptive in your management, you get 20 to 40% increase compared to just doing it as a recipe. So do not defoliate too heavily in the growing season. You want your plants to grow quickly after you've defoliated them so that you decrease your recovery period. That works for everything. And you've got to have adequate recovery before regrazing. And a lot of people don't understand the soil that they're on. If you've got a farm with very shallow soil, the rock about this deep below it, and you expect to get the results of people you've seen in a better growing area, it's not going to happen. So you need to go to the NRCS or people like that, where you can find out what's down below there and get an idea of what's the potential, and bear that in mind when you determine your planning. So research in this arena. If you want to achieve good results, you've got to have a goal. This is the improvement I want to go. How many researchers will tell you this is the goal? Their goal is actually to get a paper. They say, okay, if I do it this way, what result do we get? Is that really helpful? No, you want a guy who's saying, okay, I'm going to manage this to get the best result. That's what we're aiming for, is to find out, okay, what is the best that we can get? If you have got small plots, a couple of 100 acres, and the area that you're working in has commercial ranches of 10, 20,000 acres, that small area of the research is going to be deficient in understanding the impact on the land. So that's why we work with ranches at a commercial scale. And you remember back at the green dot slide that I showed you, and the size of the plots there, I illustrated that point there. So most researchers measure production, but not the ecological indicators that go with it. You need to understand, range science teaches that good condition range is going to be made up of these grass species. But that condition, even though you got the right species, can actually be functioning poorly ecologically if it's not capturing sunlight, mineral cycling, water cycling. So you've got to bring those things in. You've got to study the soil, how much bare ground there is, how much litter cover there is. Those are the indicators that tell you long before you're going south. Just looking at the plant species is only halfway there. Too many people elevate the animal numbers. Some of them start off by doubling the stocking rate to begin with, which is almost guaranteed to fail. And they do not proactively manage as conditions change. In dry season, you've actually got to have fewer animals, and you've got to manage them differently to achieve a good result. If you don't do that, you will not get anything like a desirable result. Even the guys in MIG and Savory, they underestimated the recovery periods, and they've only started being successful when they've actually doubled or tripled them. And research that is short term doesn't tell you very much. Guys want to do research for 3 or 4 years. It's a funding cycle. And at the end of 3 or 4 years, even if you've got really, really good management, you're only just beginning to show signs which may or may not be significantly different. So you have to go on for at least 10, 15 years in most rangeland settings in your research before you actually get a treatment difference that you can measure. And that's why when we go and work with ranchers, we work with neighbors who have been managing the same way for 10 to 15 years, so that the biology has been able to settle down to that particular management. Then you will start being able to measure differences. So what do we need to know? We need to know what is actually causing degradation or improvement. And the one thing that we concentrate is, if you're managing in a different way, like if you want to do AMP, does it work everywhere? We don't know that. So we need to include in our research, okay, where does it work and where doesn't it work? And the other thing is, just increasing the number of paddocks is not going to solve your problem. It's the way you manage within a different number of paddocks that actually creates the results. It's the same thing in business. Management pays. Everybody will tell you that. If you've got indifferent management, indifferent result. If you want to get excellent results, you better have excellent management. And that's what we're looking for. So, one of the keys is looking after the biology. These little critters, as Keith pointed out really well yesterday, drive the whole system, but they need to be fed. They improve soil structure, which is critical to getting the water in the ground, and the chief players in that are the fungi, who also provide nutrient access for plants. He showed you they're very tiny mycelia. They've got little chemicals in that at the end of the mycelia that can actually drill through rocks and get all the nutrients that are otherwise unavailable. They've got a whole network there that connects things together, and they feed back and they swap those minerals for the energy that they're getting. You've got to look after these guys. Nearly all our bad management, overgrazing, tilling, causes a decrease in them, and you've got to take care of that. They produce exudates, which feed the bacteria and fungi. They also increase the water and nutrient retention. Fungi have got a whole network underground. You look at the work of Paul Stamets in the forests in the west. They're covering hundreds of thousands of acres, all connected. They connect to the plants communicate with each other. If you break that up, you haven't got a functional system anymore. If you've got a small plot this size, or even the size of this room, where for your research, and you have excluded animals, and you're clipping instead of grazing with animals, there's a whole host of things that make the ecosystem work that you've excluded from that. So the research result that you're coming up with is very deficient compared to how nature works. Research being done at the moment shows that the higher the fungal to bacterial ratio, the higher the plant productivity. David Johnson at New Mexico is leading that particular research. And as Keith pointed out yesterday, there are built-in mechanisms in natural systems where 80% of the microbes out there are actually beneficials and help you. You've got to manage in a way that facilitates these things working well. The other friend you've got, great friend you've got, the earthworms. You can see you get different ones that operate quite differently, but they really break up the soil, as was discussed yesterday. And their poop is the best fertilizer. If you've got a healthy earthworm population, a healthy fungal population in a cropping or a grazing system, you don't need extra fertility. They will provide the fertility. You just got to manage to get to that point. Fortunately, all the people that we're with have actually reached that point, so we know this is true. The other big thing is the dung beetles and other coprophagous insects that really work for you well. I mean, they dig down and they get rid of these piles, enhancing nutrient cycling. And also the flies that lay the eggs on us, and biting flies, you get rid of them in a heartbeat if you have got a system that favors the dung beetles and they're getting rid of those things. So what we see generally with high density grazing, where you're moving every day or so, the animals bunched together like this, they drop an enormous amount of dung, increase the infiltration and reduce flies. Now when you've got a herd like this moving around, you might only graze twice in a particular paddock in a year, once in the growing season and once off. The dung beetles and all the other insects follow these little critters around. They follow the way they would have with the buffalo. So they're in high density and they actually go around the whole place, making sure that all the biological functions that were there under the buffalo are actually functioning well. So that's part of the success. So what we've seen is under continuous grazing, there's a profile. And then after 10 years, same profile, look at the amount of darkness in there, that's extra carbon. Starting off at less than 1% organic matter, up to 10%. Now, not every place is like that, but this is the range that we're seeing, and the infiltration going from less than an inch an hour to up to 10 inches an hour. Some people exceed that. Up in the northern plains, Saskatchewan and North Dakota, we have got people who have gone from 1 inch infiltration an hour to 18 inches an hour. You can have a huge storm and everything goes straight in the ground. Those guys are really making things happen, and that's just in a 10-year period. Neil Dennis is the guy, and Gabe. So let's now come back to looking at the causal mechanisms involving the ecology that's actually driving this load. Here's AMP grazing, not too far from here. Now you can't keep the thing looking like this all the time, but you can extend the number of days by grazing moderately, getting off it, and then when it's ready to graze again, you come back there. So you can keep the amount of green on the ground going for much, much longer than just grazing lightly and staying in one place, which is what this would represent. So you're fixing far more energy here than you are there, and definitely there. Water cycle, because you're getting off and you're building the carbon, it's really good there. Under light continuous grazing, it can also be pretty reasonable. We've measured that as well. But under heavy continuous grazing, where you've got a lot of bare ground, not good at all. Mineral cycle, excellent here. Poor there. And very poor here because a lot of the minerals are just being washed off with the erosion. So let's look at some different situations here. Here's AMP grazing, where you grazed about twice in a growing season and 2 or 3 times in the non-growing season. You keep it like this. Light continuous grazing, lots of grass there, bit of green down the bottom here, but not all these things are functioning really well here. The nutrient cycling is not doing very well there at all, even though you've got cattle in there. No grazing, a lot of the anti-cow people will say we need to get rid of all these animals. So here's a place not too far from here, 2 Texas NRCS individuals here. Hadn't been grazed for, I believe, 25 years. And it's dominated by big blue stem and little blue stem. And you'll say, man, those are good grasses. But it's not grazed. How much photosynthesis happening there? No. How much recruitment of species underneath there? There's bare ground underneath here because you've got these wolfy plants that shade everything else out. So your biodiversity is extremely low. You walk through there, you won't see any insects at all. You walk through here, and it's just alive with life. And that tells you that everything is working well. And when you look at the biology of the soil under these different things, we'll see a little bit of that later on. So there's a huge difference according to the way you manage. So the research we did concentrated in 3 contiguous counties there. Because we were working at the ranch scale, and in science you need the concept of replication, we worked in 3 counties that were close to each other, and in each of those counties we had an AMP grazer, who the NRCS, Nathan basically, and Tony, had identified as these guys are doing the job well. We compared neighbors, usual case scenario, which would be heavy continuous grazing, and then best case scenario, continuous grazing, which is light stocking with continuous grazing. grazing. So those are the three we compared. The results, the AMP grazing gave 3 tons per hectare per year more than the usual heavy continuous grazing. And the light continuous grazing was intermediate between them. We decreased the bare ground hugely with AMP. It was better than both of the others. Soil fertility went up. Jeff, I believe it was, who showed the results that we had, but it went up quite a bit. Because of the increased amount of carbon there, the water holding capacity and the infiltration was improved. We improved the soil microbial composition. We changed it from a 1-to-1 fungal to bacterial on the ungrazed area, the light continuous and the heavy grazing, and on the AMP grazing, it was 2-to-1. We really increased the amount of fungi. Now, part of that was when you graze in an area and you give it recovery, all the strong, taller grasses like little blue stem, big blue stem, Indian grass, they really come to the fore, whereas previously they'd been knocked off with continuous grazing. Fungi and those tall grasses go very strongly together. In fact, big blue stem is an obligate fungal plant. It needs arbuscular mycorrhizae. So the fungi was very, very strong, which is part of the reason why we got extra productivity. And the species composition changed because we were allowing the grazing to recover adequately and restoring those productive species, the big species. And the increased livestock production that went along with it. It's quite interesting. When you go on to these first places, Nathan would take me to these places, you walk on them, and you've been on the neighbors, and they've got more grass and double the stocking rate compared to the neighbors. You see the problem there? The reason they had double the stocking rate is because they were producing more grass. So they were correctly stocked, they weren't overstocked. But they were managing in a way that was producing more grass. That was evident right from the beginning. And at the beginning I thought, well, this can't be hurting the soil if they've got this increased productivity with double the number of cattle. And we went in and measured the soil carbon there, and there was a whole extra 3 tons a hectare a year being produced on the AMP grazing compared to the continuous grazing. Because we had all of these things working well. There was a longer period of green, so there was more photosynthesis. All the microbes and the fungi in that were operating well. So that just underlined, yeah, these reasons we thought were contributing are likely real. So on the strength of that research, which was done here in North Texas, basically near Munster, at Jacksboro, and near Weatherford. So we decided, well, going to the dry country, we need to know, okay, is the same sort of thing happening there? If we go east of the Mississippi, is the same thing happening there? When we come up to the northern Great Plains, is the same thing happening there? So we managed to get some grants from Shell and other people where we assembled about half a dozen of us to go and take soil measurements in those areas. Now, what we did is we located through our networks. Here you've got a fence line contrast, and we measured at the top of the slope, mid-slope, and downslope. So there's top, middle, and then likewise on this side. So we did a whole 15 little cores in there, and there. And we measured with a very accurate infiltration meter made by Decagon. And we had these guys who are professionals at the job, applied ecological services, and they came and sampled to a depth meter. Most scientists only work at 6 inches or a foot in depth, and that gives you almost no indication of what the full amount of carbon in the soil is. So we at least went down a meter on the understanding that you probably need to go down 3 meters to really get a good idea. But that's what we did in those different places. So up here in Saskatchewan, Alberta, and in North Dakota, we came up with this figure. After 20 years, we'd put this amount in the ground over and above the neighbors with AMP grazing. And not too different from here. And also, when we went to the dry country, now you can imagine in New Mexico, considerably less. And one of the things that we found was that we would pick up a change in infiltration before we would pick up a significant change in the amount of carbon. And that tells me that all the biological things were happening, but they hadn't translated into extra carbon in the ground. Then when we went across the Mississippi, where it's longer growing season, we got 7 tons per hectare over 5 years. Hugely more productive. And now, the scientists will turn around and just say, that's absolutely rubbish. You're making these figures up. And I'm going to show you, no, we're not making them up. When the buffalo ran the show with wolves chasing them, this is where the organic matter was. Conventional grazing took it all the way down here. This is where scientists do their research, okay, in a degraded situation. Now, Jeff showed you yesterday, most of these people took these measurements in areas that hadn't been grazed. A, they degraded. B, they hadn't been grazed. So all those soil functions we've been talking about had been just static. No wonder they measured no increase in carbon. In contrast, we have located the people who've been doing a good job of increasing them through the various areas that we knew, like the labs, where they showed increased carbon. We measured to 1 meter after they had shown that they developed it. So we've been measuring there and there. We know the difference between those things. These figures are real. Nathan, is he here? He's my man. We used, and Tony too, they showed us the sites, and we made sure that we sampled on the same soils in the different ranches, and he's the man who did it. He knows his game. He's measured all over the state. So coming back to this, the weakness of our approach is we didn't measure beforehand. It takes a decade or so before you get these things. So we jumped in at the end and said, okay, is there a difference after 10 years of different management between the normal way of grazing and the AMP grazers? Is there a difference? So what our stuff showed was, yes, there is a difference, but we need to tighten up our science. So what we've done is we brought up a really good scientist who trained in the UK, Christian Davies, who there's labeled CO2, where you can go to the fence line and you measure, you expose the plants to labeled CO2 on both sides of those things at the same time, and they will give you an instantaneous record for, on that day, this is how much carbon we actually fixed. That side of the fence compared to this side of the fence. And the result we come up, we're still getting this ready to publish, because we're also doing DNA analyses on the soil samples, so we know which little critters below the ground we're actually doing all the work. So that takes a lot of work, and it's kind of expensive. Anyway, what he came up with was 3 tons of carbon per hectare per year. Hey, that jives exactly with what we've been measuring. So that gives us great confidence that, yeah, we've got some substance in the results. Now, on the strength of this, the Canadians were very interested in this work, and the Canadian government gave us, there's 3 of us from our Texas team that worked with a group up in Edmonton, and they gave us a $2.6 million grant, which we've just begun to study this further in more detail in 3 of their provinces. And McDonald's and FFAR have just given us approaching $6 million to do the same study down in the south here. So we're building on that. And one of the things that we found up in Canada was that there's a very different situation with regarding depth of rooting with planted pastures and native grasses. You'll notice here, the green is the AMP, and the dark is heavy continuous grazing. At about 40 centimeters, there's a great decrease in the amount of root biomass, whereas with the native species, the roots go down deep. And we know this. The native species go down 2-3 meters. So that's one of the things that we're including. How deep do we get a positive effect? Now, these figures are unpublished. This is data that's been collected by Alan Williams, who's got clientele from Brazil all the way up into Canada. So he gave us this data. He's been measuring with these clients in all of these states. There's a number of things to look at here. He only measured to 8 inches, but that's what most people do. So this is an underestimate of the amount of carbon you can put in the soil. Years after start of AMP grazing, you can see that they started at a different place, but the rise is pretty similar between all of them. And in fact, when you calculate the mean for all of these areas, the mean, with the mean bulk density for each of those areas, it comes out as a mean over those 5 years of an increase of 8.6 tons per acre. Now that jives very closely with the previous measurement we had of 7. And I'll show you research done in other parts of the world, other parts of the US, that is very close to that. So this is a great evidence that we're on the right track. At the same time, with the same samples, also took soil measurements for the microbes, and we're having the DNA analysis analyzed now so we know which critters are actually doing the work. And you can see in every one of these places, from where they started, the microbiological activity, which as Keith showed you yesterday, is critical. So we're busy finding out what species are doing this, but we know that this is being driven by that increased microbiological activity, because the people there have been following the rules and not doing stuff that decreases your microbiological activity. So the critical element of infiltration of fever continuous versus AMP. Now you see this one, not much difference, and this one, not much difference. This one on John Cross's place in Alberta that had very high levels of infiltration, and both the continuous grazing and those guys, and this is a soil factor. We came across it on the Dixon property near Munster, exactly the same. And the Holtman area is in southern Saskatchewan, very, very dry. They'd had 4 consecutive droughts, and we think that affected that particular thing, but we're following it up later on. All the others showed a huge increase in the amount of infiltration that we measured. So now let's just talk about the effects at a watershed scale. The USDA has been studying a watershed starting here at Henrietta and ending up north of Dallas. And they've been measuring that since the early 1900s. So we've got the amount of runoff that happened in that watershed over that length of time. But we didn't have the level of stocking through that whole area for the same length of time. From Nathan and his team, we got the stock numbers for 30 years for that area. So we put in the model the number of animals that are on that area, and the model gave a 90% accurate prediction using the numbers that we knew about with what they'd measured in terms of the amount of runoff, the amount of erosion, the amount of nitrogen coming through the system, and the amount of phosphorus coming through the system. So it was very, very accurate. So the red is the runoff, just straight runoff. And this is groundwater, i.e. getting in the ground and then getting into the rivers via the normal hydrological means. So under heavy continuous grazing, most of it is running off, poor. As soon as you had light stocking, great improvement. Those error bars showed there's no significant difference there, but it was still a great improvement. The AMP grazing, which had been going for 10 years in that particular instance, a great improvement. This was a grazing exclosure that hadn't been grazed for 25 years. We had them in the different areas there. And you'll see that this was just about as good as that. Think back to the energy, the water cycle, the mineral cycle, and the biology. How good was not grazing at all? Zipper. So that had really good hydrological properties because the bulk density was low. So that was good, but there was no life there. These guys under this management are just about as good as that with all the other benefits. You can make a good living there. The biology's there, the biodiversity's there. This is pretty close to being, yeah, this is what we can do. So the nitrogen loads that we calculated followed the same deal. Very high under continuous grazing. Much better, better. And the same story with phosphorus. So this means that we are looking after the land for the general population as well. One of the functions we have to do because we actually look after the land. So we're looking after our individual properties, making a better living on them, and also helping the population in what they need. So I'm going to diverge now. Most of my research has been done on rangeland, but now that we're involved right around the country, not everybody's doing just range. They're doing range with a little bit of forages and a bit of cropping. And what we've learnt in the process, which came up yesterday, is when you include AMP grazing in a cropping cover crop system, you get huge advantages, and that's just what we're going to talk about now. So this is on Gabe's place about 3 years ago. Cover crop, and that day, it was in August, I believe, but it was 90 degrees, as hot as Hades. And the neighbors looked pretty sorry, but these guys looked pretty good because their soil had been built up. So soon after that picture was taken, they did their daily move. Here's the electric fence. They put the cattle in there. This was taken in another portion of the deal where this is showing them moving. And I wanted to show you the amount of litter being left behind. This was discussed a little bit yesterday. Is this wasted? Nope. At the beginning of the season, you don't want to knock them down like that. You want to have a high graze to trample ratio. But as the stuff gets away from you, let them graze, get the good stuff, but you do it in a manner where you have a high trample to graze ratio. So then you put this on the ground, and it just makes the earthworms and everything just take off. So that's what drives the system. You've got to manage for those little critters as well. So that's what's happening there. So you guys know Gabe's story. He was in trouble because he had a couple of series of droughts and he couldn't borrow money to buy fertilizer and stuff. So he went back to the drawing board and worked with the NRCS. First of all, they started off with no-till, some improvement. Then crop rotations. So that improved things as well. Then bringing in cover crops as part of the rotations jumped it up further. As soon as they moved from 3 or 4 species in the cover crops to 25 plus, it really jumped it up. And that's one of the really good things that we need to do more detailed research on it. But because so many people are getting the results, if I was farming, I would go with this information. I don't need a guy writing a paper about it to tell me that this works. But then when he brought his AMP grazing, and he does AMP grazing really well, it just really skyrocketed. From there, 3.5 up to 6.5. And we believe that's continuing. Got a bit of time. So the other thing too, I've just used Colin Seiss's information. What's happening at the same time as you're putting carbon in the ground, as you're actually increasing all these other things. Now Keith explained in detail yesterday. If you're just putting on NP and K, that actually reduces your microbial content. So you start losing all of these other things because the microbes aren't actually making them available. But if you go back to biological management, with good management, then you actually bring these things back because the microbes are actually driving that and making them available. That means better nutrition for the plants, for the livestock, and we believe for the people. So we need to continue doing research on that. Here's another example from Georgia. 1,000 millimeters of rain, and they measured soil to the depth of, I believe it was 8 inches here. So old cropping land that had been really cropped out was in poor condition, low levels of carbon. They changed it across to permanent grassland and under some irrigation with dairy cows. Now they obviously fed their cows to bring up the energy levels, and they put inorganic fertilizers on there. And this is the reason I'm showing you this. But the figures they got, there was a bit of a lag phase after the beginning, and then it shot up. Same figures that we've been coming up with, around about 8 in those areas where you can really grow things. That's only at 30 centimeters. If you went down a meter, I reckon you'd probably just about double that. Anyway, the point I'm trying to illustrate here is it suddenly peaked and then plateaued off. We don't understand why, because all the stuff we've been looking at, we've been following some of these guys like Gabe for 15 years, and it's just came up and up and up and up. The only thing we can think of is that these guys were still using inorganic fertilizers, so it put a ceiling on the biological activity. We've got to test this hypothesis. That's just an observation at this point. Here is what's happened up in Saskatchewan and North Dakota. Over a 10-year period, they've moved from that to that, and this is what they've achieved. we've just measured as part of our big grant up in Canada, we've just measured on Neil Dennis's place. And the neighbor, the university, not us, the university students who actually don't believe in AMP grazing, they think it's a crock. They measured on the neighbor 0.8 of an inch an hour infiltration. They went across to Neil's place and they measured it in long lines and everything, a mean of 18 inches an hour infiltration. So that's an independent assessment that jives very closely with what we've been doing. And hopefully we'll change a few minds with that. Now that's not happening down here because we've got different soils. So one of the things that we're doing in looking at from here right up into Canada is how does the different soil respond to these things? And in order to help people, we have to understand that. And we're working with NRCS and those guys to actually do that. So we are under attack as people who think animals are part of the solution by a lot of people around the world. And their biggest beef, as they say, cattle in particular, put out too many emissions. Now, I got a little bit of a problem with that because, as a fool of mine said, using worse language that I'm going to use, anybody can have a little cage that he puts the animals in and measure the CO2 that comes off. Is that how it works in the real world? Not even close. Let's have a look at that. So we took our figures, the amount of emitted by the cattle and the amount sequestered. Even under the poorest grazing we measured, it was, and then if you change HC, high continuous to low continuous, you got fewer cattle, half the number of cattle, so you got less emissions, but you're putting a huge amount in the ground, way, way more than the emissions. And even under AMP grazing, which you've got the larger number of cattle, but your margin, because the extra amount that you're sequestering, is still great. Now, a colleague of mine, as part of our research team up in Michigan, he's a Texas boy, Jason Roundtree. So he running on planted pastures there, he had this differential, no fertilizers involved in there, just a grass legume paddock managed with AMP grazing principles. And he compared that with, in summer sometimes they have to have irrigation periodically just to fill in a gap so they got decent quality product through the year. So the emissions were higher because as soon as you start using gasoline and the expense of putting irrigation out there, that has got a carbon footprint. So when you add that in, then you're still way ahead of the pack. Now these situations are on grass only, but they don't represent the cattle industry. Because if you take animals from this, where the sequestration far exceeds the emissions, and you put them in a feedlot, they inherit the carbon footprint of corn, transport, and everything involved with the whole production cycle that involves feeding corn. That changes things completely. So we've yet to do that, but we're having to tread carefully, because when we started asking questions and working with Alan Williams, who's one of our partners, the advice we got back from everybody, you need to be very careful about who you say is doing a bad job. If you tell the corn guys that they are part of the big problem, you will be dead. You will never work again. So we have to, okay, corn is really good in grazing. So if you have a grazing thing in corn, even that doesn't keep them happy. But that's what Alan Williams is doing. He's getting his good gains with his grass finishing with mixed cover crops and stuff like that by grazing, measuring the bricks and stuff like that on corn and all the other things in there. You can do it, but you're still messing with these guys, so we're having to treat carefully. But you can bet that if you had a grass-only system, or even if you were feeding grain that was produced the way the Rodale Institute does, and they produce stuff that has a very negative carbon footprint, they're actually putting more carbon in the ground than the crops are producing the way they do it. If you do that, you'll have a whole of agriculture with livestock that has is a sink, a very strong sink that offsets a lot of the industrial living that we do. But we're a long way from being able to even talk about that in wider circles. So that's what we're doing. Now, you'll notice that I concentrate and work with leading farmers. These are the reasons. Addresses things at the commercial scale. It integrates commercial science into whole growth responses. Think back to what Keith was talking about and the complexity of what you're dealing with and how these things interact with each other. We need to know those things. We don't know what happens on a small plot where you've taken all those interactions out of it. So that's the cornerstone of our research. It also identifies emerging properties. If you've got the fungi working well and the earthworms working well, there's a synergism. You add dung beetles to that. There's work in the UK. I was invited to speak to the Royal Society a month ago. And they've had experiments on there at Rothamsted where they were incorporating grazing, but then it got expensive. So they said, no, we're going to do cutting instead. They've got 14 species of dung beetles. Obviously, those disappeared completely. That's got to decrease the amount. So soon after they actually did this, they switched from grazing, everything plateaued off. And I think it's because they're not using their full system. A supposition, but that's an observation I've made. So the other thing is a human element. It's been known for a long time with the art of farming. Those people who can put things together in a way that really succeeds are a small part of the population. But they can produce results that are so much better than the average. Those are the people we've got to learn from. And we've got to learn about the synergisms and how they do that to be able to get other people to do the same and move in the right direction. And that's what we hope to do. The other thing, too, is we have found people who do a good job of managing adaptively to improve the land while increasing their financial situation. Those two things go together. You can't sell anything if you're not going to actually improve the financial situation. You need to do the two together. So that's what we hopefully will learn by doing it this way. And the other thing, too, what characterizes research in agriculture is how many scientists actually consider the unintended consequences of the stuff they're trying to tell you to do. Like, I'll tell you some of the unintended consequences. The dead zone in the Gulf. The anoxic lower third of the Mississippi. The amount of soil we lose from agriculture is 3 times higher every year than the total crops of corn, soybeans, and hay. Is that sustainable? No. We just about wiped out pollinators that are the baseline for all living things. Those are unintended consequences, a direct result of the way we as industrial people operate. Fortunately, there are people who've shown us a way to actually get away from that. So, let's move on. What have we learned from ranchers? Now, I know I'm going to irritate a lot of people by putting this, but this is from Walt Davis and Dave Pratt, both of whom really know what they're doing. They work with a lot of good ranchers. It takes a minimum of 10 paddocks just to stop overgrazing. If you're ranching with 8 or fewer paddocks, you're not rotationally grazing, you're rotationally overgrazing. You're staying in long enough to keep nubbing off the species that you want, and you're coming back before they've recovered. You might be on a slow move downhill, but you're going downhill. To support decent animal performance, it takes 14 to 16 paddocks, even with good management. The most rapid improvement in your resources takes 30 or more paddocks that you're moving through for the reason I said. You can have a short period and allow adequate recovery and change your stock numbers adequately. The biggest decrease in workload and greatest improvement has been with greater than 50 paddocks. This is from guys who are doing it. Been doing it a long time. Many of them 30 years. That's got some substance to it. So the fastest and cheapest way to create more paddocks is just to combine herds. So it doesn't cost anything. You just got to know how to do it. And if you want to begin this, go to a chap who's done it, learn from him, so you don't make mistakes. 1 herd reduces workload a lot. Checking 4 herds takes much longer than 1 herd. productivity per acre is improved without decreasing animal performance because they're moving regularly, they're on an even plan of nutrition, and that works really well. Long recovery periods, absolutely critical. Carrying capacity and total productivity increase at low cost. And you've got to have elements like do not move to the next adjacent paddock, but move to the one that's recovered the most. And that's why if you looked at the picture that they had of the different layouts there, you've got to be able to move around the place because rainfall often isn't even over your property. When we were operating on the Wagoner Ranch, we had 35,000 acres we were operating on. We had 30 rain gauges over that area. So we had got a very good handle on how things vary in each rainfall event. So you've got to keep your eyes open. So we have done field work for the ranchers. We've also done modeling, financial and watershed modeling and grazing modeling. And our net results, all of it published. These are the guys here. Now, more recently, until 2 years ago, I didn't know about these two German teams that have been working in Namibia and Argentina. They've been coming up with identical results to what we've got. Ecological function and profitability increase with an increasing number of paddocks. Short periods of grazing with adequate recovery give the greatest profit and ecological function. Adjusting grazing management with changing conditions increases ecological and function and profitability. And the converse of that is if you have fixed protocols, you don't get anything like the same results. So, yeah, that explains itself. And we've got figures from the field and figures from our modeling that show that there's about a managing adaptively gives you 20 to 40% greater increases than just moving it at fixed time periods and from fixed paddocks to the other. You've got to think about this game. Profitability decreases if recovery is too short or too long. Every environment is going to have different requirements. In the dry areas, it's going to be different to the wet areas. Tall grass is going to be different to short grass. For instance, in the tall grass prairie where I've done most of my work, as soon as you leave it too long and the plants are going across to setting seed, that's when your animal performance will drop off. So you have to time your recovery periods so that you don't get hit by that. And if you're just developing lots and lots of grass, but it's low quality, it might look good, but it's going to hurt your animal performance. So you've got to get that right, and you can do it. There's enough people out there doing it that we can learn from them. And stocking rates can be increased without damaging ecological function as the number of paddocks is increased. What this trait translates into is adaptive stocking is less sensitive to overstocking than constant stocking. The advantages of AMP over continuous are less important at low levels of stocking, but are very important at high levels. The people who want to hit the high end and get the profits, they can do so at the same time as building up their land and increase their profits at the same time by having many paddocks. It gives you much more flexibility and ability to control your overgrazing. So short periods with the greatest number of paddocks. So the Germans and ourselves, these are the German teams, results in higher net returns, lower income variability, one of the really important things. Through droughts, if you're managing well, you can actually protect yourself quite well by having many paddocks. At the same time, protecting the resource space and facilitating the restoration of a wide range of management scenarios from 8 inches of rain up to 80. So there are many advantages. The way you achieve those is to aim at improving this in order to get that. And that's important because most people don't appreciate that. They just take the resources as a given and don't think they're having a negative effect. You've got to change that attitude. You've got to match your numbers timelessly before the prices go down in a drought. Spread the grazing over the whole ranch so that you don't kill small little portions which actually spreads until you've hit the whole ranch and it's degraded. Defoliate moderately, short grazing periods, adequate recovery, and adjust forage growth as rates change. I must say a thank you to the Dixon Water Foundation, who've done a gigantic amount for conservation, supporting Kivera, various conservation groups right around the world, and they've paid for most of my research. The government guys at universities and that, they think AMP grazing is a crock, and unfortunately they try to show that it doesn't work. And I learn from people who are making it work and document what they're doing, and I think we're in a stronger place than they are.